Hello, my name is Saad Lamouri, and this presentation will show you the basic steps in solving a Kaggle competition. So you're just a starting data scientist. You have some background, some theory, but where do you start? Where can you get some experience in applying the theory you've just learned? And one great way to learn and apply some of the material I've learned is Kaggle. Kaggle is a website that contains several data science competitions, some of which offer real money for the top winners, and other competitions are simply for learning purposes. And one example that we selected for this presentation is the Scikit-learn tutorial. Scikit-learn is based on Python, but we chose to solve this particular competition using R. So the prerequisites that you need for this presentation is Kaggle account. That's easy to create. You need to download R, and you need to install RStudio. RStudio we find is an easy editor to work with, and if you're gonna work with R, if you're gonna use R on a regular basis, we recommend RStudio. So the basic approach to solve any Kaggle competition, and really those are the very basic steps. You need to download the data from the competition itself, from the Kaggle website. You read in the data into memory. You partition the data into a training and testing sets. So basically you will build a model to train the data, and this model will use your training data set. Then you use the test data set to validate the model. You submit the results to Kaggle that will compute a score and return the score to you right away. And you can go ahead and fine-tune the model. Resubmit again to Kaggle until you reach a point where you're satisfied with your final result. So let's delve in. So now that we've downloaded the data, we need to read it into memory. So we're reading the training predictors. We're reading the training classification results, and we read the test data. The test data is all the data for which we don't have any results and for which we have to compute the classification results that we need to submit to Kaggle at the end of the competition. One question we ask here, we don't know much about the data, we don't know where it came from, no information was given to us. So the first thing we look at is there any relationship, any correlation among the data? So we run the choregram command in R to see how much correlation exists, if any, among the data. And the darker the color in the resulting figure, the higher the correlation. And in this case, well, there is some correlation we can see, but not a whole lot. So, well, there is some correlation, so perhaps we can gain from reducing, in this case, the dimension of the problem. So instead of having 40, which is the case here, 40 predictors, maybe we can reduce the number of dimensions from 40 variables to much less than that to make our prediction more accurate. So what we do here is we apply the principal component analysis. In R we can use prcomp on the entire data set, and we can choose, generally when we run a summary here, we can choose the around 80%, a little bit above 80% of cumulative proportion. And well, after experimenting, we find that choosing about 14 variables gives us good enough results. And so here we choose the first 14 components, and we reconstruct our training data based on those 14 components. And in this case as well, we are given the first 1,000 entries. We do know the predictor results, we do know the classification results, and it is on the remaining 9,000 data that we have to guess the correct result. So next, what we need to do is partition the data set. The idea here is we'd use about 75% of our training data. We will use it to actually train the model, and the remaining 25% of our data set, of those 1,000 entries, we'd use to validate if our model is any good or not. The next question is, well, which classifier should we choose? And there's quite a few of them to choose from. We can experiment here. Our data set is not large, where we can choose to experiment with a few of them and see which will yield the best results. In this presentation, we will show you the support vector machine, the SVM. Generally, SVM is a model that performs pretty well in Kaggle competitions. Before we train the model, the first step we have to do is find the best parameters for the SVM model, and that's crucial because the gamma and cost values will have a direct relationship on the performance of our model. And for that, we use the tune SVM command, which is part of the E1071 library in R, and we feed it our training data, and we let it figure out what it thinks is the best gamma and the best cost values. Well, the next step then is to use these values to train our model. We use the SVM function against the training data set with the values of gamma and cost that were just computed, and we get a training accuracy of about 100%, which is not bad. But the question is, how will the model perform against data that it had never seen before? And for that, we run the predict command against the remaining 25% of the data, which is the test data. And here we obtain a testing accuracy of about 95%, which is pretty good performance. So we have 12 wrong predictions out of about 250 data points. So what remains to be done now is to use our model to predict or make predictions on the remaining 9,000 data that Kaggle gave us to predict. And we do that, we store it in a file. I call it here predictions.csv, and we upload it to Kaggle to compute the results. So to recap, what we did was we created a Kaggle account. We chose a particular competition. In this case, it was the Scikit-learn competition. We chose a prediction model. We trained it. We tested it against the test data set, and we uploaded the results to Kaggle for scoring. So those are the basic minimum steps you would have to do when you participate in a Kaggle competition. If you're curious about the code, you can find it in GitHub. If you have any questions or comments, please forward them to me at slamouri@gmail.com. Thank you for your attention.